Hi. So now let us see one of the graph traversing technique, that is breadth first search. In short, we can call as BFS. Okay. So in graphs, we can start the traversing from any vertex actually. So for better understanding of this algorithm, so let us take one simple graph here. So this is what the graph we are going to take. So in this graph, we can start the traversing from anywhere actually. Okay. When you are traversing this graph, we are going to maintain three colors for every vertex actually. So it is going to tell its status. Okay. So what are those statuses? Let us try to observe first of all. So here if you see, blue color is representing that not at visited, because you are traversing means we are going to visit every vertex, right? So blue color is indicating that that vertex is not at visited. And then next green color is representing, if any vertex have green color, that vertex is enqueued but not visited. So here actually we are going to use the data structure Q. So if that particular vertex already enqueued, then it is going to have the color green actually. Then red color means it is visited, so everything is done. Okay. So then let us see visiting order. Let us note down the visiting order here, and then let us have the queue here. This is the queue data structure which is going to have front and rear. Then you see, as we told, we can start the traversing from any vertex. Like in linked list or trees, we are going to have a default element actually where you have to start the traversing. But in case of graph, you can select randomly any vertex in the graph actually, and then from there you can start traversing. So in that way, first of all, we are going to select the vertex, that is A actually. So the moment you selected the first vertex, first of all you must enqueue that vertex actually. So that is why you can see we are going to enqueue that vertex into the queue. So as we discussed, if any vertex is enqueued, you can see the three statuses. Green color is saying that if any vertex is enqueued and it is not visited, so you just change its color to green actually. So that is why we must change the color of vertex A is to green. So that you can observe. Then after this what you have to do, see here we are going to repeat the steps actually, same steps we are going to repeat. So what are those steps? Let us try to understand clearly. So now you have a question, what is the vertex I have to visit? So whenever this question is arised, it is very simple, you just perform the DQ operation. So in the DQ operation, whoever is coming out, so A is coming out because it is the first element. So A is coming out, so that vertex you have to visit. So it is very simple that whenever you perform DQ operation, who is coming out from the queue, that vertex you have to visit next. So that is why vertex A is visited. So that means if any vertex is visited, we must change its color to red, right? So that is why vertex A color we are going to change to red color. After that, after changing its color to red, that means we visited, what you have to do? Identify all adjacent vertices which have the color blue actually. That meaning is identify the vertices which are not at visited and which are not at enqueued, both actually. So that means simply you can say identify the vertices which are not at enqueued. That means simply blue colored vertices, right? So that means in this case for the A, adjacent vertices are B and C, and both B and C are blue colored. Now whatever vertices you identified which are not at enqueued, those vertices in any order you enqueue them actually. So that means B and C. So first B and then C, or first C and then B. In any order, all adjacent not enqueued vertices you can enqueue into the queue actually. That means all blue colored vertices, all blue colored adjacent vertices, you simply enqueue them. That's it, simple. So that means B and C, first B and then C, we are going to enqueue actually. So that is why you can see front is B and then C. So now if you see, after enqueuing B and C, what you have to do? you must change its color, right? So that is why B color we are going to change to green, and C color is also going to change to green, because you enqueued, of course not visited, but you considered its meaning is. Then again the same question right now. So what is the question? What is the vertex I have to visit next? That means whoever is in the front in the queue, that vertex you have to visit. That means you simply perform the DQ operation. Whoever is coming out of the queue, that vertex we are going to visit. So if you perform DQ operation, B is coming out. So that means you are going to visit next B. So that is why it is moving from A to B actually. So because B is visited, its color is changed to red. So that's it. After that, what we have to do? So that is why let us try to note down the steps here so that we will have the clarity. Whenever you have a question, what is the next node? So what is the next node to visit actually? Next node to visit. Then whenever you have this question, what you have to do? Simply what is that node is, you simply perform DQ operation. So DQ operation if you perform, so whatever is coming out from the queue, that node we are going to visit. So that means visit that particular node. So we are going to visit that node actually. Now after visiting, what we have to do? Change its color to red actually. Change its color to red because we visited. Then after that, what we have to do? So after visiting, identify blue colored vertices. So find blue colored vertices. Blue colored vertices actually. And NQ them in any order. NQ them in any order actually. So this is what we have to perform. And of course we have to change their color to green actually. So these are the steps we are going to do repeatedly. Now let us see, when you are at B, so you DQ'd, so B came out, so you visited B, so that is why we change the color to red. Now here, identify adjacent blue colored vertices. See, for B, adjacent blue colored vertices are what actually? D and E. Of course A is also adjacent, but A is already visited. So that is why only D and E we are considering. So that D and E in any order you can NQ actually. So that is why you can see we are going to NQ D and E in any order. So that means D and then E we NQ'd actually. Because we NQ'd these two vertices, we must change their color, right? So that is what, because we already considered. So for what purpose we are doing, we will understand. Okay. Now D and E is NQ'd, changed their color also. So that means, so last step is also done. That means now again the question. What is the question? What is the next node I have to visit? Again same thing. Perform the DQ operation. Who is coming out? C is coming out. So visit that particular node. That is why change its color to red. So say C color we are going to change. And then find blue colored adjacent vertices. So for C, you are at C now. Blue colored adjacent vertices meaning is what? Adjacent vertices which are not at considered, that means which are not at NQ. So here F and G not at NQ. So those two we are going to NQ into the Q actually in any order again. So that is why F and then G we NQ'd actually. So here you can see, so we have to change their color to green. F and G we are going to change. So this is what the status after C visited, after C iteration is completed. Then same question. So from here again you are going to the same question. Now what is the next node? So the next node is whoever is in the front actually, that is what D. So D is coming out. Now D you are going to visit means change its color to red. And then after changing color, identify adjacent blue colored vertices for D actually. So only H is there, that H you can NQ. and then change its color to green. So now what is the next node we have to visit? Whoever is in the front, that is what E is coming out of the queue. So we are going to visit E. So because we are visiting E, we have to change its color to red. Now let us try to understand the importance of green color. See, for the E, adjacent vertices are B and H. But B already visited, H is of course not yet visited, but you already enqueued, right? So who is enqueued H? That is what D actually. D already enqueued. That is why though H is actually neighbor to E, you no need to enqueue now actually, because it is already considered. That means already placed in the queue. So that is why already H is there in the queue. We no need to again enqueue. That is why if first time is already enqueued, that means already considered, you no need to put again into the queue actually. That is what the green color indication. So E is not going to enqueue any vertex. So that is what it's over at E also. So what is the next node we are going to visit? So whoever is in the front, that is F is in the front. So that is coming out of the queue that we are going to visit. That means change its color to red. And same discussion even here also. Who is the neighbor actually? Of course C and H are neighbors, but C already visited, H already considered. So even F also not going to enqueue any vertex. So that is why it is going to the next node for visiting, that is G. So change its color to red, and then even for G also same discussion. So H already enqueue. Now what is the node we are going to visit next? That is what the H we are going to visit. So we visited H, so change its color to red actually. So now you see, when you are going to stop, you see as we told, we are executing the steps like this. So here you see, when you reach the last line, we are going back to the here actually. That means again you are asking what is the vertex I have to visit. Then here you see, whenever you dequeue, is there anybody in the queue? So because there is nobody in the queue, what is that? What is its meaning? So there is no vertex for visiting. That means you are ensuring all vertices are visited. But there is a one condition when you can say all vertices are visited. If you call only one time BFS, if graph is connected. If graph is disconnected, so it is not possible to visit all vertices with a single call actually, BFS call. But assume that the here given graph is actually connected graph. So we can say by the time Q is empty, all vertices in the graph are visited. So that is what now Q is empty, so all vertices are visited. That is why you can observe all vertices colors are red. So this is what the BFS algorithm. So it is very simple. Okay, you can select any vertex initially, place that selected vertex in the queue, and then start the asking what is the vertex I have to visit. So you simply perform dequeue operation. Who is coming out from the queue, that vertex you are going to visit. Then immediately after that, identify adjacent blue colored vertices. That means adjacent not enqueued vertices. Enqueue them in any order and change their color to green actually. So this we are going to repeat until Q is empty. That is what the termination condition for this algorithm. So this is what breadth first search. So now let us see BFS tree actually. Okay, that means in which order we visited. So first we visited A, after that we went to B, and then we visited to C, and then we went to D, and then we went to E, then we went to F, and then to G, and then we went to H actually. So this is calling as BFS tree. Okay. So now for getting the more clarity, what we will do is we will try to write down some other possible BFS orders actually. So that is what BFS traversals. So let us take one. First one is, so if I start with A of course, but I am not enqueuing the vertices B and C. First I am enqueuing C and then I am enqueuing B. Then because front is in C, so you are going to visit C first, and then that means you are visiting C first means either F and G or G and F you have to enqueue in the same order. So that means I am going to enqueue F followed by G. Then next we are going to visit B, that means D and E, or E and D actually. So that is what I am going to NQ E and D. And then of course we have H. So this is one possible BFS order. Or let us take another order. So I am going to start with H actually. So if I start with H, you see what are the adjacent vertices? D, E, F, G. In any order, see 4 factorial permutations are possible. So any permutation you can take and then you can NQ them. So simple. So that is why I am going to take in reverse order, that is G, F, E and D. See, basing on your initial permutation, that is what G, F, E, D we taken, accordingly next vertices will be there, because you see next you are going to visit G means first you are going to NQ C actually next after this. And of course F is not going to NQ anything, but next E is going to NQ B actually, and then of course C will NQ A next actually. So this is what different possible BFS orders. Okay, so like this, after understanding this, try to write down different BFS orders, then get the confidence. Okay, so this is what overall breadth first search. We are going to maintain 3 colors for different status, and we are going to use the data structure, that is Q. And observe that every vertex exactly once we NQ'd actually. That is important thing, but that is not possible in case of depth first search. Okay.